In this work, we have just taken the neem as a specific plant source from where we have collected the dried flower, and by using this dried flower, we have synthesized the natural dye. As we all know today, AJO dye has a very concern for the environmental and societal life, and because of that only now the natural dye are generally preferred by the society. Actually, plant source are the major source for the natural dye production because the plant source have the very specific pigment material. They have the specific insoluble current, and which color is generally like a metallic colorant material. And these specific dye that is synthesized from the plant source, they show a very good opacity in terms of the light fastening and the color favorable also, chemically inert also, and eco-friendly also. Because of this only, currently we are favoring this natural dye in place of the AJO dye. But there is one specific limitation for this dye that this natural dye have a very poor bonding with the textile fiber material. So we need to add a specific mordanting agent for the as a metallic mordant or some of the specific biomordant also we have used in this study, so that the binding of this dye with the specific textile fiber will be very good. So in this work, firstly we have taken the dry flowers from the Azadirachta indica, and then we have sterilized it properly. After that, we have grind it, and then we have prepared the different extract for the organic solvent like ethanol, acetone. We have taken by taking the concentration to 2% to 10%. Then we have extracted the dye by using the Soxlate apparatus at 80 to 85 degrees Celsius. And after that, we have filtered out this extract dye from the solvent. And further, we have done the phytochemical screening and the antimicrobial property for this dye. Now, for the phytochemical analysis property, we have found these flower extract in the aqueous solvent and the ethanolic solvent. They show the presence of the carbohydrates, saponin, amino acid, quinone, flavonoid in a very good amount. So we have selected the aqueous solvent and ethanolic solvent for our further study. Now, in case of aqueous solvent, when we have performed this antimicrobial property, so we have, in the case of Pseudomonas aeruginosa, we can see this is the gentamicin we have taken as a standard antibiotic. And beside that, we have taken this Fa, that is the aqueous extract, Fm, that is the methanolic extract, and Fe, that is the ethanolic extract. So after the comparison of this ethanolic, methanolic and the aqueous extract, we have got a very good zone of inhibition across this aqueous extract, that is approximately the 25 millimeter. Similarly, we have performed the antimicrobial activity test against the E. coli, and the E. coli also in case of the aqueous extract in compared to this methanolic and ethanolic, we have got a very good zone of inhibition that will be slightly lower than that of the Pseudomonas, that is the nearby the 15 mm. Similar property we have observed for the Bacillus cereus, where this aqueous extract has shown the very great high level of the zone of inhibition. So after performing the antimicrobial activity, we have selected this aqueous extract for the synthesis of the natural dye. So how we have synthesized the natural dye? We have collected the flower from the neem plant, and after the sterilization and filtration, we have ground it into the very specific powder, fine powder. Then in this case, we have added a specific mordant. Here we have added the three types of the mordant. First is the ferrous sulfate we have taken, and second copper sulfate, and in the third we have taken the green tea. Green tea we have taken as a biomordant for the as a mordanting agent. Then after that, we have checked the dye fabrics criteria on the basis of the cotton. We have taken the very, that is the white base of the cotton fabrics, and we have cut it into the very small size. Then we have dipped this small size fabrics into the specific dye that is treated, that will be mixed with the ferrous sulfate, also copper sulfate, and this biomordant. Then we have analyzed their texture. So after this analysis, we have found that in case of the copper sulfate, we have found a very specific gray type of the, but the color we can see very, that is not a uniform type of the diffusion we have shown in case of the copper sulfate and the neem extract. In case of the ferrous sulfate also, we have found a very diffuse form of the spread of this dye across the cotton fiber. But in case of the green tea, we have done the two experiments here. First, we have taken this cotton fabric and directly treat with the green tea as a biomordant. And in this case, we have got a very uniform, that is a very uniform brownish-like structure for this. And then we have mixed this biomordant with the neem extract, and then we have treated the fabric. And here also we have we have seen a very good result as compared of the green biomordant. Now after that, we have studied the effect of the different temperature. Here we have taken the temperature from 30 to 100 degrees Celsius, and we have whatever the diet we have got after the green tea, and this green tea biomodern dye I have selected here, and then we have kept these dye fabrics for the 1 hour into the different temperature. And here the color extent we can observe the similar color of extent up to the 100 degrees Celsius. This show a very good finding for our finding that this neem extract that will be supplemented with a biomodern that have a very high stability for a higher temperature also. After that, we have tested the light fastness tested, where in the sunlight we have kept our fabrics, and we can see the degree of the fading of the color is up to the 72 hours. So we have got a very good that is the light fastness test up to the 48 hours for our dye fabric. Similarly, for the detergent solution, we have taken the different concentration of the detergent solution, and here the 1% detergent solution for the 30 minutes at the 50 degrees Celsius. That shows a very good result for our diet. So this is all about the morphological analysis of our dye related work. Then for the group analysis, we have analyzed to the FTIR spectrum analysis. So here first we have done the FTIR for the undyed cotton fabrics. After comparing with the sulfate mordant, which we have used for the copper sulfate here and the ferrous sulfate here. In this case, we have got a very specific, that is the wave number, that is wavelength across the 1371. And this 1371, in both fabrics, we have shown this bonding, and this reflect the presence of the sulfonate ion. It means that this shows that our dye has been entrapped onto the cotton fabrics with the help of this ferrous sulfate and the copper sulfate. For the green tea and the neem dye that is associated with the green tea, we have got a very similar type of the FTIR peak for both cases. But in case of this neem extract, we have got a very specific peak across this 1371, 1407. That shows the presence of the specific CH and the keto group also. So now we have taken this biomodern green tea associated with neem extract for the same analysis, and in this cotton fabrics we have found a very scaled fibrillar structure for this cotton fabrics. And after the elemental analysis, we have found the presence higher percentage of the carbon and the oxygen, and very less percentage we have obtained for the copper and the fluoride. So this also shows the eco-friendly nature of this cotton fabrics with the percentage of the higher amount of the carbon, oxygen and nitrogen. So finally, I like to conclude that this is a very good finding for my research work and for my research scholar. And in this case, we are also working on the acacia also and other medicinal plant also, that we are also implementing the consortium of these plant extract with the dye, and so that we can suggest a effective natural dye for the society also, which are very eco-friendly for the societal benefit. So this is all about my work. Thank you.
Good evening, everyone. My name is Gobinda Prasad Chutia. I am the research scholar of Department of Chemistry in Guwahati University. I am going to present my work on Mesua assamica seed cell derived recyclable Bronsted acid nanocatalyst for biodiesel production from different oil feedstocks. Now, the biodiesel is a renewable oxygenated fuel, which is known as monoalkyl esters of long-chain fatty acids produced by transesterification of oils and fats. It has numerous advantages, including the biodegradability, non-toxicity, low sulfur content, and reduced hazardous emissions. The bio-waste-based catalysts derived for the production of biodiesel have several advantages. They provide the non-toxic, low cost, and lower reaction steps. The biomass-derived magnetic nanocatalyst provides high reactivity, high recovery rate, and recyclability nature. We developed a magnetically separable acid catalyst from the waste Mesua assamica seed cells. The waste Mesua assamica seed cells were first burned open air to make them ash, N followed by the thermal treatment to activate the biomass S. After that, the sulfonation was carried out by using the concentrated sulfuric acid at a ratio of 1:10 at different temperatures from 80 to 150 degrees centigrade for different reaction periods. We determined the sulfonic acid density and total acidity of the derived acid catalyst. The density of the sulfonic acid and total acid was determined using the titration method. We found that as the reaction temperature was increases, the acidity of the catalyst was increases. The observed drop in acid density at extreme higher sulfonating temperature may be due to the present process other than sulfonation, such as dehydrogenation or oxidation. However, the longer sulfonation times have shown to saturate the carbon surface, which results the lower sulfonate group anchoring. The XRD analysis of the catalyst showed the presence of magnetic iron oxide in the catalyst surface at different 2 theta values. Similarly, the FTI analysis of the magnetic heterogeneous catalyst was conducted. It also shows that the presence of sulfonic acid absorption bands at 1182 and 1055 centimeter inverse, which represents the successful sulfonation on the activated biomass surface, as shown in the black graph over the FTI spectrum. The elemental analysis of the magnetic heterogeneous acid catalyst was conducted to determine the different concentrations of elements. Similarly, the XPS spectrum also conducted. The C1 spectrum of thus in the C1s spectrum, 2 peaks were observed at 284 electron volt and 288.6 electron volt, which suggested that the carbon was associated with a variety of functional groups, including the hydroxyl carboxyl, graphitic sp2 carbon, and sulfonic acid groups. The conformation of sulfonic acid groups in the catalyst surface is verified by the binding energy peak for sulfur 2p spectra at 168.4 electron volt. We also conducted the FECM and FETM analysis to determine the surface morphological structure of the catalyst. The spherical iron oxide magnetic nanoparticles were shown by the efficient picture of figure A. The presence of porous surface is shown by the efficient picture of activated charge is shown by the figure B. The sulfonated magnetic catalyst image shows some resemble random seeds-like structure, where some agglomerations were occurred due to the possibility of some magnetic interaction between the particles. The magnetic catalyst is core cell structure as suggested by the FETM picture as shown by the figure D, where the surrounding S color was represented the biocide materials, whereas the inside dark circle of the pseudo-spherical particle indicates the magnetite iron oxide particles. Based on the particle distribution size, the average per size was determined to be 87.4 nanometer. Now the transesterification for biodiesel production. The transesterification was carried out using Mesua, assamica oil, soybean oil, and Azadirachta oil with prepared acid catalyst and methanol. The reaction was placed in a hot plate stir fitted with a reflux condenser. We also examined the effect of variable methanol to oil ratio and variable catalyst concentration at different reaction temperatures. And the obtained biodiesel yield was calculated using the formula. The catalytic activity showed that optimum process conditions, that is at 7% of catalyst load and 9:1 methanol to oil ratio at 60 degrees centigrade, the Mesua assamica biodiesel showed maximum biodiesel yield that is 96.8%, followed by the soybean biodiesel 95.8, and Azadirachta biodiesel yield was 95.3. It is due to the various nature of the feedstock which influence the catalytic activity for biodiesel production. The FFA content, moisture content, and fatty acid chain length and unsaturation of the oil have significant influence on catalytic activity for biodiesel production. The FFA reacts with alcohol to produce fatty acid alkyl esters and water, which leads to lower the activity and reduces the product yield. The water also increases the degree of hydrolysis. However, the longer alkyl chains, steric hindrance, and more energy hinder rate limiting nucleophilic attack by the alcohol. Similarly, the unsaturated fatty acids, higher unsaturated fatty acids exhibit a decrease in reactivity due to their non-linearity, which could slow down the rate of diffusion and reactivity and ultimately reduces the product yield. The saturated fatty acids are linear shape and can readily absorb on the catalyst surface through the pores, so that so that they can show the better catalytic activity. We can see that the Zatrava's oil have higher number of FFA content, higher content of long chain and unsaturation, and provides a lower biodiesel yield as compared to Mesua, assamica, and soybean. Now the catalyst reusability test. The reusability investigation was conducted at optimum conditions of 78% catalyst 9:1 methanol to oil ratio at 60 degrees centigrade using the Mesua assamica oil. An external magnet was used to separate and recover the magnetic catalyst, and the multiple washing in petroleum ether was conducted to removal of glycerol and other absorbed molecules from the catalyst surface. After that, the catalyst was used in a subsequent esterification process after being oven dried for 6 hours at 100 degrees centigrade. It was found that in third cycle, the obtained biodiesel yield was 75.3%, whereas in the first cycle, it was 96.8%. The reused catalyst showed progressive drop in the catalyst acidity and sulfur content, which lowers the catalytic activity and reduces the output of biodiesel, as shown in the table. It was found that the total acidity and sulfonic acid density was reduces as the catalyst cycle was increases. Now the conclusion, the study explored the development of magnetically separable acidic nanocatalysts by using the waste Mesua assamica seed cells for sustainable biodiesel synthesis. The conversion of seed cells into magnetically separable catalysts in biodiesel production offers a cheapest green pathway. The sulfonated catalyst displayed acidic density of 3.9 millimole per gram and sulfonic acid density of 1.8 millimole per gram is well enough to perform an effective transfer reaction. The catalyst provided maximum 96.8% biodiesel yield as fresh catalyst and 75% yield as third recycled catalyst under optimized process conditions. The study also found that high FFA content, moisture content, and longer fatty acid chain length and higher unsaturation have negative influence on the catalytic activity and can reduce the product yield. These are the references. Thank you.
I'm a research scholar in the Department of Physics, Kajino University. I am going to present my work, synthesis and characterization of Cu-Al-O based Delafossite by ball milling process. This is the overview of Delafossite structure. Delafossite structure have general chemical formula AbO2, where A is the Cu, copper and silver, and B is the group 3 element like aluminum, boron, chromium, and Cu-Al-O2 Delafossite has a rhombohedral crystal structure and belongs to the space group R3M. Our main objective of this research to synthesize Cu-Al-O2 using ball milling and to characterize its properties. This is the historical background of the Delafossite material. Delafossite firstly was discovered in the early 20th century, 1997. And after the discovery of the Delafossite material, these materials have been studied for their conductive and optical properties. And Delafossite material Cu-Al-O2 is a p-type semiconductor, and it has a good optical transparency in visible range. And it also has the optical band gap greater than 3 electron volt. Previous researcher synthesized the Cu-Al-O2 Delafossite by using the solid state reaction, Sol-Gel method, and hydrothermal synthesis. This is our methodology to synthesize the sample, Cu-Al-O2 sample. We have used a high energy ball milling to achieve nanostructure using the planetary ball mill with tungsten carbide as milling media. And this is the milling parameters. We have made a sample for 70-hour duration with 370 RPM speed, and we have taken ball to powder ratio 5:1. This is the flow chart of sample preparation. Initially, we have taken copper oxide and aluminum oxide in 1:1 molar ratio in an air mortar, then grinded it for 10-hour duration under dry condition. Then we go through the ball mill for 70 hours at 370 RPM speed with ball sample ratio 5:1 in acetone media. After ball milling, the milled powder was dried at 155 degrees centigrade for 3 hours. And then we go through the heat treatment, and the ball mill sample was heated up to 1200 degrees centigrade in air at heating rate at 10 degrees centigrade per minute for 6-hour duration. This is the thermolysis, and this is the TGA data collected from our synthesized sample, heated up to 1200 degrees centigrade with a heating rate 20 degrees centigrade per minute in nitrogen atmosphere. This is the curve weight loss and derivative weight loss percentage versus temperature. The previous literature we have seen initially around 900 to 950, that is below 100 degree, 1000 degrees centigrade, copper oxide and aluminum oxide reacted and formed spinel phase CuAlO2-4. Then after increasing the temperature up to 1150 degrees centigrade, the spinel phase CuAlO2-4 decompose and produce Delafossite phase CuAlO2. For phase analysis, we have taken the X-ray data. Figure 2, left hand side figure shows the X-ray data. This reveals the conformation. This reveals the formation of the CuAlO2 Delafossite phase with minor unreacted aluminum oxide and spinel phase CuAlO2-4. A CuAlO2-4 spinel phase may occur during the cooling duration. And we also plotted the Williamson-Hall plot to calculate the crystallite size and microstrain from the X-ray data using the modified Short's equation, and we get the crystallite size about 48.9 nanometer from Short's equation, and from Williamson-Hall plot 134 nanometer, and microstrain 1.25. We also calculate the bulk density and porosity using the Archimedes principle, and we get the bulk density 2.79 gram per centimeter cube, which is almost 58% of the theoretical data, and porosity we got 40%, around 40%. For bond analysis, we analyze the FDR spectra of the synthesized CuAlO2 sample. This is the FDR spectra of our synthesized sample. Here, peak at 873 arrived from ALO stretching vibration. It distorted ALO6 octahedra, and 650 and 587 centimeter inverse represent the copper oxide, copper oxygen and aluminum oxygen stretching vibration, Cu and ALO stretching vibration. This confirms the formation of Delafossite CuAlO2. This is the morphology of the sample, which reveals some porosity with some porosity and interlocking agglomeration were noted, and there is a various in shape, various shape in particle, cuboid and hexagonal. We also analyze the dielectric constant and micro hardness. Figure shows the dielectric constant versus frequency curve. Initially the dielectric constant decreases with the frequency up to 1000 Hertz. Then it remains constant throughout the higher frequency, which confirms the semi-conducting nature of this material. And this is the hardness we have calculated using Vickers impact method. We got the dielectric micro hardness about 0.91 gigapascal, and the insect image is showing the Vickers impact. Conclusion: we successfully synthesized CuAlO2 by ball milling process, which confirmed by XRD and FTR analysis, and we got the bulk density 2.79, which is 58% of theoretical density, and morphology of the sample is revealed by SEM, which indicates agglomerates with some porosity and interlocking, and dielectric constant of CuAlO2 initially decreased up to 1000 Hertz and it remains constant at higher frequency, which confirms the semiconductor nature of the CuAlO2. It is a potential candidate for electronic and photonic applications like electrodes in photovoltaic cell, flat panel display, light emitting diode, etc. Lastly, I'd like to thank Material Science Department, Material Science Center, IIT Kharagpur for providing the facility, and for giving the opportunity. I would like to thank Kazi Nazrul University Asansol, and for financial support I would like to thank CSI UGC, Government of India. These are the references. Thank you.
Good evening to all of you. Myself, Keval Bambharoliya, pursuing PhD under the guidance of Dr. Hemandayan Patel at Kadi Sarva Vishwavidyalaya, Gandhinagar. Wait a minute. Hereby I am presenting on the topic of discussion of the novel dischiff base ester with the 2-amino benzothiazole containing liquid crystalline derivatives, studying for the new antimicrobial agent at the conference of International Conference on Composite Materials for Environment Protection and Remediation 2024, organized by the Department of Chemistry, GB College. Now, abstract. The benzothiazole and dischiff base ester are pivotal particle practically due to their extensive variety of the biological multifarious and have an extensive range of the therapeutic distinct as well as liquid crystalline demand. Keeping in view the significance of this organic heterocyclic compound, a new series of the 2-amino benzothiazole consisting novel dischiff base ester derivative were integrated by the organic reaction. The integrated organic heterocyclic derivative were evaluated for them in vitro antibacterial activity against the gram-positive and gram-negative bacteria. The homologous of the lower members revealed an anisotropic nematic mesophase, whereas the higher mesophase displays a schematic A mesophase. Introduction. Liquid crystal are fluid phase of matter, whereas the constituent molecules are sufficiently disordered to be classified as a liquid and generate a flow properties, yet retain a variety degree of ordering depending on the actual type of liquid crystalline phase. Liquid crystals have many useful applications in scientific and technological areas, in particularly as display devices, organic light emitting diodes, anisotropic networks, photoconductor, and semiconductor materials. High demand of new liquid crystals for application has led to the preparation and study of numerous mesogens, in particularly thermotropic. Over many years, a large number of thermotropic liquid crystals containing heterocyclic units have been synthesized. This research field have grown even more largely to improve of the improvements in the synthesized methodology. The incorporation of the heterocyclic moieties as core unit in the thermotropic liquid crystal can result in large changes in their mesophanes and physical properties because they possess more polarizable heteroatoms than carbon such as nitrogen, oxygen, sulfur atoms. Many mesogenic compounds containing heterocyclic rings such as pyridine, pyrimidine, furyl, thiazole, thiophene, oxadiazole, benzothiazole, and benzothiadiazole have been reported in the literature. Heterocyclic ring fused with the benzene ring are also becoming popular mesogenic cores to be incorporated in the molecular structures. Now this is my scheme, sir. 4-hydroxybenzaldehyde is reacted with the 2-amino benzothiazole in presence of anhydrous ethanol to give a skip base that is intermediate 1. Now in second, this 4-hydroxybenzaldehyde react with the 4 converted into ether derivatives. We are reacting with the alkyl bromide moiety in presence of diacetone. And this again reacted with the para-amino benzoic acid in presence of anhydrous ethanol and catalytic acetic acid to give the intermediate B, which is again a azo compound, amino compound. After that, A and B combined in presence of the DCC and DMAP in THF as a solvent at RT to give a dischiff ester derivatives, where R is equal to Cn H2n plus 1. Here N is equal to 1 to 8, 10, 12, 14, and 16. That is carbon chain. Now this is, I have taken one example, N is equal to 6 moiety, in which I spectrum shows 3015, 2983, 2865, 1728, that is ester functional group, 1686, 1675. This is of azo imine moiety. 1435, 1376, 1286, 1171, 1065, that is of ether, and 725, that is of CS moiety. And in NMR, one protons at 9, which is singlet of azo, and another one is a 8.52, that is of another 8 azo moiety. At 8.30 to 8.10, that is multiplet of 3H hydrogen. 8.01 to 7.87, that is multiplet of another 3H hydrogen. 7.70 to 7.53, multiplet 4H aromatic hydrogen. 7.35 to 7.01, that is multiplet of 6H aromatic hydrogen. And 4.14 triplet, that is of CH2 attached to the oxygen. And 1.76 multiplied to it, that is CH2, which is attached to the C2, which attached to the oxygen link. 1.46 to 1.25, that is multiplied of 4H to CH2 group, and 0.90 at last at CH3 group, methyl group. In lower side, DSC shows that one of my compound converted into schematic A from group pneumatic mesophase, in which schematic phase is observed at 140 to 150, and which is converted into pneumatic phase at 260 to 270 degrees Celsius. This is photolyzed optical microscopic liquid crystalline diagram, sir, in which first image shows a schematic A diagram and second one shows as a pneumatic diagram. This is the antimicrobial activity. The table describes the antimicrobial.
Keval, you have just hardly 2 minutes to complete. Okay, so please try to be in time.
Yeah, okay, sir. The table describes the antimicrobial activity of the synthesis compound in micromilligram per ml concentration. The antimicrobial activities were performed against the S. aureus and Bacillus and P. orogenous bacterial strain, while the antifungal activity was performed by against the C. albicanus strain. The gentamicin was used as the standard drug against the bacterial strain, while the malconazole was used as the standard drug against the fungal strain. Against the S. aureus and strain compound 1 and 2 show potent activity as compared to the standard drug of gentamicin, and 3 and 4 the equipotency. Against the B. substilius strain, compound 1 and 2 and 3 shows the potent activity as compared to the standard drug, and 4 and 5 the equipotency. Against the P. orogenous strain, compound 1, 2, 3, 4, and 5 shows the potent activity as compared to the standard drug. In case of the antifungal activity, compound 1, 2, and 3 shows the potent activity, while 4 and 5 compound show equivalent potency compared to standard drug. Conclusion. In this paper, we describe the synthesis and mesomorphic behavior of a homologous series of 2 amino-benzothiazole consisting of novel dischiff base ester derivative were integrated by organic reaction. The homologous of lower members revealed anisotropic pneumatic mesophase, whereas higher member displays the schematic mesophase. The study also revealed that the length of the alkyl chain gives significant effect to the mesomorphic property, in which schematic F phase can only be observed of mid to long-term derivative. The MIC value of the test substances were determined by the greatest dilution that totally stopped the growth of the test organism, expressed in micromilligram per level for the antibacterial and antifungal activity. That is the reference, sir. Thank you.
Good evening to all of you. Thanks to organizers to giving me opportunity to present this presentation. Basically, my presentation is gallium nitride based SOI-TF-FinFET to enhance the linearity and distortion in a high frequency application. Basically, what is there? First, there was the silicon based FinFET devices. Because silicon, it has a problem at the low for the very less dimension for the nanometer. When the dimension is less than 100 nanometer, then silicon it create the problem. Then we go for the FinFET devices. There is a gate all around. There is a better control of the gate. Now we have after the silicon devices, after the CMOS devices, we switch over toward the FinFET devices. But again, at the FinFET, at the low dimension in nanometer order, again there was a problem. Then we should go toward the SOI FinFET. Now again there was some problem in a SOI FinFET. Then we have to move toward the gallium nitride FinFET, because gallium nitride SOI type the FinFET, it is better because the wide band energy gap, so it can sustain at the high temperature, high power it can be handled on, even though because of the high mobility of the gallium nitride and better control of the gate, it is better device as compared to the other device. So what is the outline? First, we have to give the abstract, introduction, proposed device design, then the result, then conclusion, then the references. Abstract, basically we have said already you that this FinFET, it gives the better performance as compared to the analog performance, and as compared to the linearity and distortion performance. So why we have to we have done the we have done the some analysis with the help of the TCAD, that this proposed device, it is better than the other device. So what basically we have done, we have compared the gallium nitride SOI-TF-FinFET with compared to C-FinFET, TF-FinFET, SOI-TF-FinFET, and we have try to give the as comparing the result, we have tried to analyze that this give the better performance in as concerned to the analog performance, even though this gallium nitride SOI-TF-FinFET as compared to the other FinFET, it give the better result at the RF frequency in comparison to the linearity and in comparison to the distortion. Because at high frequency at the receiver end or at the transmitter end, there may be the frequency harmonic distortion. So we have to try to prove that this device is better as compared to this device. As compared to the proposed design, this is the design. This is the gallium nitride. Channel dimension is 7 nanometer. There is a source. There is a drain. Silicon on SiO2, so it is a SOI gallium nitride SOI FinFET, because at the base it is truncated. So why it is a truncated FinFET? Truncated means that from the base side its dimension is very less, so that in gallium nitride SOI interface it gives a better result as compared to the all other type of the FinFET. So as concerned to the analog performance, we can say that this gallium nitride TF FinFET, basically it gives the better result as compared to the conventional FinFET, TF FinFET, SOI TF FinFET, and as compared to the transconductance, the proposed design device gallium nitride TF FinFET, it gives the better result as compared to all other devices. So we can say that as compared to analog performance, our proposed device, it gives the better performance as compared to the other devices. Basically, there is another parameter at the RF frequency. There is a linearity and there is a distortion. More the linearity, this is a better device, and distortion it should be less as minimum as may be possible. So there is basically there is a two type of the problem. One is suppose that there is a two frequency F1 and F2. There may be harmonics 2F1, 3F1, second harmonic, third harmonic. Even though in presence of the F1 and F2, there may be also third harmonic intermodulation distortion. 2F1 minus F2, 2F1 plus F2. Basically, these are called as intermodulation distortion, and they create the problem at the high frequency because they comes into the bandwidth of the design device. So that ultimately at the receiver end or at the transmitter end or at the high frequency, we have to design the device that should give the better linearity, and distortion it should be minimized. As As per the result, as per the TCAT result, second order transconductance value for the second harmonics, for the second order distortion value of transconductance value, it is minimum for the gallium nitride, and third order transconductance value for the proposed device, it gives the minimum value as compared to the other devices. So in terms of the second harmonics and third harmonics, we can say that this proposed device, gallium nitride SOI-TF-FinFET, this gives the better result as compared to all other devices. Even though for the transmitter, for the receiver, for the better linearity, intercept point, it should be high. Intercept point, because it is that point at which input power or output power both are equal. So if it is a high, then it is a better give the linearity result. As per the TCAT analysis, IP3 value for the gallium nitride SOI-TF-FinFET, it gives the maximum value of the IIFC3. So we can say that this gives the better result. This gives the better result for the linearity. It means the proposed device, it gives the better linearity as compared to the other devices. Even though the third order distortion value, okay, it should be minimum as compared to the other devices. So if we compare the IMD3, it is very less as compared to all other devices. It means that for the linearity, for the distortion, for the intermodulation distortion, for the 2F1 and F2, 2F1 minus F2, they comes into the bandwidth range. It gives the better result as compared to the compared to the all other existing devices. So we can say that our devices, it is better as compared to the all other devices as concerned to the intermodulation third order harmonics. Even though we can say that there is a presence of the second harmonics, third harmonics, and it should be minimum either at the transmitter end or at the receiver end. By the conclusion, by the TCAT analysis, we can say that gallium nitride proposed device, it giving the less distortion, it giving the less value as compared to the all other existing devices. Same for the SD2 and same for the third order distortion HD3. Even though there is a one also the parameter 1 decibel compression point, it is the point at which input power and output power differ by the 1 decibel. More the value, there is a more better the linearity. So we can say that for the gallium nitride, the proposed device, it gives the better linearity as compared to the all other devices, because 1 decibel compression point for the proposed device, it is the maximum as compared to the all other devices. So we can say that our proposed device, it gives the better analog performance because there is a more drain current, there is a better transconductance value. Even though the second harmonic, third harmonic in our proposed device at a high frequency, it gives the lesser value. And even though the intercept point value, this gives the higher value, so the linearity is better. So for the proposed devices, analog performance is better, linearity is better, distortion is better. So we can say that this device, it may be highly applicable at the RF side design. This is the references, and thank you very much to all of you.